Find out the least number of complete years in which a sum of money put out at 20% compound interest will be more than doubled. So here, let's say a sum of money which is P rupees has been deposited in a bank at compound interest. The rate of interest is 20%, and at the end of X number of years, the amount, which is P, now becomes double itself. So the total amount A is equal to 2 times P. And we have to find out the time within which this is happening. Now this is a case of compound interest. So what is going to happen is that at the end of every compounding period, which in this case we will assume is every year, the interest accrued during that period, let's say it is I1, is added to the principal at the beginning of that period. So the amount at the end of, say, first year becomes P1 equals to P plus I1. And this P1 then becomes the principal for the next compounding period. And then interest accrued on top of that, which is interest accrued on P1, will be added to P1, and that will become the amount or the principal for the next compounding period. So at the end of the second year, the amount will be P2 is equal to P1 plus I2. So now we have to find out as to within how many compounding periods will this amount P become double itself. So now we know that for compound interest, the formula for amount is equal to principal multiplied by 1 plus R by 100 to the power n, where n is the number of compounding periods and R is the rate of interest per compounding period. So let's fill in the values that we know in this example. So amount is expected to be twice the principal, and this is equal to principal multiplied by 1 plus R, and R is 20, divided by 100 to the power n. Now we can cancel this P on both the sides. So or 2 is equal to 1 plus 0.2 to the power n, or 2 is equal to 1.2 to the power n. Now here we have to find out the least number of complete years in which the sum of money will be more than doubled. So what that means is that we have to find the value of n so that 1.2 raised to the power n is equal to 2 or greater than 2. So let me use my calculator here. So 1.2 to the power 1 is of course 1.2, which is less than 2. 1.2 square is 1.44, which is also less than 2. 1.2 cube is 1.728, which is also less than 2. So let's take the next number. So 1.2 to the power 4 is 2.0736. So this is higher than 2. So we can say that the number of years in which the sum of money will be more than doubled is n equals to 4 years. Now let's try to solve this using a different method. So we have this equation, 2 is equal to 1.2 to the power n. So previously we have seen the hit and trial method. Now let's try to use logs. So log of 2 is equal to log 1.2 raised to power n. Now we know that log x to the power a is equal to a log x. So using this formula, log 2 is equal to n log 1.2. So let me pull my calculator here. So 2 log is 0.3. So 0.3 is equal to n multiplied by, so log 1.2. So 1.2 log, so n multiplied by 0.079. So or n is equal to 0.3 divided by 0.079. So 0.3 divided by 0.079 is 3.79. So n is equal to 3.79. Now we have to find out the least number of complete years. So definitely the amount will not be doubled in 3 years. So the next complete year is 4 years. So we'll take n is equal to 4 years within which the amount will double itself.